Now that we know what vectors and scalars are, we can now talk about vector operations. So operations is how we add the vectors, how we multiply them, how we divide them, and how we subtract them. I'm going to start by multiplication. Multiplication is easy because just like 2 times 2 is equal to 4. So when you multiply something by 2, you're just doubling that thing. You are increasing whatever you are multiplying it by, that factor that you are multiplying it by. So if you have 2, you are going to increase 2 by a factor of 2, so it becomes 4. The same thing if you have 3 times 6. The thing that you are doing is you are taking 3 and increasing it by a factor of 6, which becomes 18. So this the number that you are multiplying it's a factor, so it takes one value and then increasing it by a factor of that number that you are multiplying it, which means that we will now have 6 3s which make up 8. The same thing when you are working with a vector quantity and you want to multiply it by a scale. Remember that a scalar only has a magnitude. So you are basically just taking your vector and then multiplying it by a certain factor. Remember that to represent a vector is represented by, you can use a line, an arrow, and the magnitude of this line represents the magnitude of the vector. The length of this line of your arrow represents the magnitude of the vector that you are trying to represent, and the arrow represents the direction. So if I draw my line like this, that means that I have a certain amount acting in this direction. Another if I want to go to the left, I will change it and make the arrow point to the right, make the arrow point to the right. Now let's say that we have a vector, some vector b. Remember, we need to add an arrow at top to show that it's a vector. But then whatever vector this is multiplied by 2, meaning that we multiply it by some magnitude, and magnitude is a scalar, right? So now we are increasing it just like we did here, increasing 3 by a factor of 6 and making sure that we have 6 3s. We are going to also have 2 b's, which means that we increase it by the factor that we are multiplying it by. So this b will now be twice this length because we multiplied it by 2, which means it becomes twice. But it will not change direction because a scalar is just a magnitude. So it does not, in this case, have an effect on the direction. So when you multiply it by 2, it will be in the same direction, but it will be twice as long. And now it will become 2b because it has been multiplied by 2, which means now it becomes twice what b was, right? Now let's say you have another vector in the same direction, and let's call this vector c. Now what happens if we multiply this vector by a negative scalar, meaning that we multiply it by -2? What's gonna happen is that every time we multiply, we increase the vector. Always remember that every time you multiply it, you increase the vector, which means that the magnitude of this vector will now be twice as much, right? It will now be twice as much and become 2c instead of 1c because it has been increased by a factor of 2. But because we multiply it by a negative scalar, it now goes in the opposite direction. You remember in equations we said that if you have x plus y equal to 3. If you move y and transpose it to the other side, it becomes negative. The same thing happens with vectors. If you multiply them by a negative, they change direction directly opposite. It doesn't change by an angle, it changes directly opposite. Now, a positive vector times a negative vector will be negative. You know this from algebraic operations, that negative times positive is negative. And we represent negative by saying something that is negative means that we are going the opposite direction, right? If we had a vector that was going this direction, and it was a negative vector, and we multiply it by a negative vector, negative times negative is positive. So this vector would have become positive and changed direction. That is to say, anytime we multiply a vector by a negative scalar, it changes direction and goes the opposite direction to what it was going to. So if you have a force, if you had a force of 3 kilonewtons that is going to the left, a force of negative 3 kilonewtons will go to the right. We don't even have to write the arrow anymore, because this negative tells us that it is going the opposite direction. Then if you don't want to write the negative, you'll write 3 kilonewtons, but you'll have to show the arrow that it now goes in that direction. Every time we deal with a vector, you must show the direction. And this here, in this case, the negative is sufficient to tell us that it is going in an opposite direction to what we say that the positive is. So that's how you multiply a scale. Your vector, you multiply a vector by a scale. Your vector will increase by a factor of whatever you are multiplying it. And if your scalar is negative, then it will change. It will now go in the opposite direction. The same thing, the same ideas work with division. If you have a vector b that is long, and then you divide it by 2, division is simple. It's just gonna be now half of it, because you are now dividing it by 2 and saying, okay, I'm decreasing it by a factor of 2. It will now become half b, but in the same direction. But if you had b, if you had c going that direction and you divide it by -2, then for the fact that you divided it, it will become smaller by a factor of 2, which means it will become negative. But because the 2 was negative, it will change direction. The negative always changes the direction. So the difference between multiplication and division is that with multiplication, your vector will increase by the factor that you are multiplying it. And if the factor that you are multiplying it is negative, it will now go the opposite direction. With division though, it will decrease by that factor, meaning that if you divide by 2, it will become half of it. If you divide it by 3, it will become 1/3 of the size that it was. They work the same, just that multiplication increases the magnitude, division decreases the magnitude, and the sign of your factor changes its direction. What if you had vector A and you had another vector B, and vector A, and they were not going into the same direction? How would you add the two vectors? We follow a law called the parallelogram. The parallelogram law of addition. Remember, a parallelogram is a four-sided figure where opposite sides are parallel to each other. So this side will be parallel to this one, and this side will be parallel to this side. So a parallelogram is a four-sided figure where opposite sides are parallel to each other. So that means that we are going to take these two vectors and add them using parallelogram. So we are going to make a four-sided figure whereby these two vectors are included in that. Now, the first thing that you're going to do, you are going to take these two vectors. Let's change this vector and make it green so that we can see properly. Now, we are going to take vector A and make sure that it touches with vector B at their tails. This is vector B and this is vector A. Make sure that they touch at their tails here. And now we are going to draw imaginary lines. And these imaginary lines are going to represent the other two sides of the parallelogram that are parallel to these two vectors. A parallelogram is a four-sided figure whereby opposite sides are parallel to each other, which means now I need a line here. I will draw an imaginary line that is parallel to vector A. And then I will draw another imaginary line that is parallel to B. This line is parallel to B, and this line is parallel to A. And now I have a four-sided figure, and opposite sides are parallel to each other. Now, to add the two vectors, I will now present a new vector that goes from the tails and goes diagonally like this inside until it reaches the other corner of the parallelogram, and that will be my resultant vector quantity. So this, it is the addition of these two vectors. Remember that what we do, we join the two vectors at the tail. We make sure here they were not touching, they were just arbitrary acting wherever they are acting. Now to add them, we come and put them next to each other. We draw imaginary lines that are parallel to them, and then we draw a diagonal that goes from their tails, and then that will be their addition. We'll make examples so that you understand how it works with values. So A plus B will give you vector R, the resultant vector. Now, another way that you can do it, here we put them tail to tail. So they will touch tail to tail. What if we wanted them not to touch tail to tail? We can do the same thing and say, okay, vector A will act. Remember, it must not change direction. Remember, you can move a vector anywhere you like as long as it doesn't change its direction. So I can move it from here and come and put it here, but it must still be acting. It must be the same size and the same direction. Now, instead of putting B at its tail, I now put B here at its head, and then it goes like this, and then I put B here. Now, what will be our resultant? If we join them tail to head, here they were, they were tail to tail, and we're using the parallelogram law of addition. But if we put them tail to head, meaning that the tail of B starts at the head of A, our resultant vector will start from the tail of A and go all the way to the head of B. And now we have a resultant just like that. Now, this is not parallelogram law. This is a special triangular law of addition. Now, these vectors are added in the same way. It's just that here I used a parallelogram, here I used a triangular law of addition. You can use either one that you are comfortable with, especially when we start adding values to the vectors and it becomes a little more complicated. Now, with vector subtraction, you have to pay attention because there's a little trick here that might throw you off, and then it might affect how you subtract your vectors. Now, let's say we have vector A still in the same direction. You have your vector A and you have another vector B that acts like this. Vector B. Now the operation that we want to do here is take A, right, and subtract vector B. Now, how do we do that? The first thing that we are going to do is to separate B from this negative sign. So we just take it as if our A is being added to a negative B. So instead of just saying A minus B, we are going to separate it and say, no, we are actually adding a negative vector. Now, if you are listening, you now know what a negative vector is. If we see a negative sign, we now saying our vector is acting in an opposite direction, right? So if we are going to add A and B, we are going to take A still in the same direction because our A is positive. But when we subtract B, we are adding a negative B, meaning that our B is now acting in an opposite direction, meaning that our B is now, let me actually draw this A here. We now have A. Our B, instead of going this direction, it now goes in this direction. And if we use the parallelogram law of addition, we now will draw a parallelogram where this side is parallel to this side. We'll draw another line that is parallel to vector A. And now our resultant vector will be a diagonal. Remember, we put them tail to tail, we draw a parallelogram, and then we draw a line that goes diagonal. Even here, we do the same thing. We put them tail to tail, but our B is now acting in the opposite direction. It is now going that way. So we draw our parallelogram and draw a diagonal. Just for fun, let's see what would have happened if we added them. We draw an A, we draw a B, they must touch. That's A. And then we make a parallelogram. It must be parallel to the opposite side. It must be parallel to that side. So now let's draw a diagonal going from where they join diagonal. It will go like this. These drawings are not to scale, but you can see that if we were adding them, this resultant would have been way long. It will be a very long vector. But here, when we change direction, our resultant vector is a very short one to show you that we have subtracted them here while we have added them here. So when you are adding, when you want to subtract vectors a minus b, just know that we are just adding a to a negative b. So that b, it changes direction because of the sign of b. It now goes in an opposite direction to what it was supposed to go in a direction. Now let's quickly do a triangular law of addition and see how it would be. We would have an a that is going in that direction, right? That is our a. And then at the head of a, we draw b. It starts at the head instead of joining them. It now goes in this direction because it's negative. And then our resultant will start from here and close the triangle. And now you can see that it's more like the same thing. I actually enjoy the triangle over the parallelogram. Other people do not. Now in the next video we will do a lot of examples and talk about the sine law and the cosine law that we are going to solve our vectors. Let's talk about the addition and subtraction of collinear vectors. Now when we say they are collinear, it means that they are acting on the same axis. For example, if you have a the vector a and you have the vector b also acting in the same direction. So number one, how would we add them? Addition. Now how do we add vector a and vector b that are acting on the same axis? Even if they were going upwards or downwards, it will still act the same way. Now the way that we add them is that we are going to take vector a, and then after we put vector a, we join vector b. It must touch vector a directly like this and then go in whatever direction it's going into. Now the resultant force is going to go from the tail to the head of the last vector, which means that our resultant vector will be from here until here, acting in their direction. Now we have a resultant there, and that resultant represents a plus vector b. They will give you their resultant. Even if you have a b that is going the other direction, that is to say, how do we add a negative b and we add it to a negative a? What will be our resultant? Now you must remember that a negative a means that it is acting in an opposite direction. When you are doing algebra, you know that -2, -3, you add them and you keep the sign. So you have -5. You add them 2 plus 3 and you keep the sign. Even with this one, if you have two negative vectors, we are going to add them and then keep the direction that they are going in. Now suppose that they are negative, so they will go this direction. So we will join b again in that direction. They must touch. Now our resultant vector, we will add them, meaning that we'll have a vector that covers them both, and we must keep the sign, meaning we must keep the direction that it is going in. Now that's how you add two vectors to each other, but in a collinear that are acting in the same axis. But how do we subtract them? Now when I say subtract them, I'm saying we have a positive. Say that our positive is to the left, our positive vector a, and we have our vector b again. Now the operation that we want to do here is we want to find A subtract B when they are co-linear, acting in the same axis. What will be our resultant? Now remember, what we are going to do is now say, okay, detach B and say we are adding a negative B. Instead of saying we just subtracting B, we are now going to say no, we are adding a negative B. And once we say negative, we are basically saying our B changes direction and will now act in the opposite direction. So we represent it this way. We will have our A, which is positive. Our B, however, will change direction. Instead of going to the right, it will now go to the left. You see here, I joined them right next to each other so that they can show me how long my resultant is. But if they are acting in opposite direction, my B will now act, I will put it under so that I can see the difference. And by the difference, I mean that I want to see how much space is left here, right? And that will be the magnitude of my resultant. It will be this size from here to here, because that's the space that ends after I also put vector B. Now, which direction is our resultant going into? Because vector has magnitude and direction. If I have negative 2 plus 5, the same thing I did here. If their signs are not the same, we are going to subtract them and keep the sign of the bigger number, which means it will be 5 minus 2, which is 3, and we keep the sign of the larger number, which is positive 3. You can see that 5 minus 2 is positive 3. If I have negative 8, let's do it this way. If I have 2 minus 8, how much it will be? This 2 is positive, so I will subtract them and say, okay, I can see that I have 6, and I will keep the sign of the bigger number and have minus 6. So the same thing happens here. We are going to keep the direction of the larger vector. Since A is going that direction and it is clearly the bigger one, our resultant will also go in the direction of A. And that's how you subtract two vectors to each other. Now see, our B was actually going this direction, but because we are subtracting it, we now add it as a negative vector, meaning that it is now going the opposite. And we put them next to each other and see how much space is left in between. Now, when you are doing examples, you will be given magnitudes, real magnitude, meaning that if you have a box and you have someone, let's say you have a guy here pushing it at 5 newtons, and you have another guy who's pushing it at let me throw the guy. This guy is pushing it at 2 kilonewtons. Now, because this guy pushes to the left, that means his 2 kilonewtons are negative. These two vectors are going to subtract each other. Now we want to know if this box will stay where it is or will it move, and which direction will it move in if two people are pushing it at these two forces. Now what we are going to do is that we are going to take an actual measuring tool and say, okay, each centimeter, 1 centimeter represents 1 kilonewtons. So if he's 5 kilometers, that means it's 5 centimeters. So I'm going to measure it and say, okay, that's 5 kilometers, because you can see my ruler here. Let me zoom in. My ruler is 5 centimeters in that direction. That's person number A. Now, person number 2 acts in the opposite direction that way, and he acts at 2 kilometers, so his force will only be 2 centimeters. So I'm just gonna give him just 2 centimeters from exactly here where he ended, and say, okay, from 4 2 centimeters. Now, before we even find the resultant force, we know that a force acting at 5 minus a force acting at 2, we must be left with 3 kilonewtons to that direction, right? So even here, that's exactly what is going to happen. We can see that we have here and we have here. So let's see how much that is. We fill up the space that is left after you subtract this one, and we take the direction of the larger vector, so it must go that direction, and we said that direction is our positive, so we can see that it will go that direction. But if you see here on my ruler, if you really zoom in there, you can see that my ruler says this is 3 centimeters. The same way here, 5 minus 2 is 3. So you can see that if you do them exactly to scale, this 5 minus 2 gives you 3. And that's why we say that if they go in different direction, you will draw one in one direction, draw the other in another direction, and your resultant is whatever space that is left there. And that's how you add and subtract coplanar vectors.